Hello friends, in this lecture we are going to study fins. See students, fins are also known as extended surfaces and this topic is very important, interesting as well as conceptual topic of heat transfer. Fine. Now see, consider any surface. Let that surface be maintained at surface temperature 400 Kelvin and the ambient temperature or the surrounding temperature be 300 Kelvin. So there will be heat loss from the solid surface to surrounding air by means of convection. And from Newton's law of cooling, Newton's law of cooling, we know that Q convection is equals to H surface area into temperature difference. Fine. See, rate of heat loss by convection is product of heat transfer coefficient H into surface area of the solid body into the temperature difference between the surface temperature and the surrounding temperature. So in order to increase the heat transfer rate, if we want to increase Q convection, either I need to increase value of heat transfer coefficient H or either I need to increase the temperature difference or I need to increase the surface area. Fine. See, in fins, what we do? We increase the surface area. However, we do not change our heat transfer coefficient nor we change our temperature difference. Now see, how to increase the heat transfer coefficient? Consider a body at 80 degrees Celsius and it is placed in a room at 20 degrees Celsius. What will happen to this body? Eventually this body will cool and it will attain the surrounding temperature. Suppose the cooling takes place in 2 hours. Fine. Now what I do? I place a fan here. When I place the fan, what I see, the rate of cooling increases and the body changes temperature from 80 to 20 in only 10 minutes. Fine. So the first case was that of free convection and when I have placed this fan, then the case becomes of forced convection. So we see that heat transfer rates increases in forced convection. So by placing this fan, what we are changing? We are changing heat transfer coefficient H because value of H is more in forced convection and value of H is less in free convection. Fine. Now see, temperature difference Ts minus T infinity. Consider a body at 60 degrees Celsius. When this body is placed in winters, the surrounding temperature be around 5 degrees Celsius. So the temperature difference available for heat transfer is 55 degrees Celsius. However, when this body is placed in summers, what will happen in summer? The body temperature 60 degrees Celsius, surrounding temperature 40 degrees Celsius. So change in temperature or temperature difference is 20 degrees Celsius only. So heat transfer rates will be high in winter and heat transfer rates will be slow in summers. So we cannot increase the temperature difference in summers. However, this temperature difference is high in winters. Fine. So we have seen that there are some limitations of increasing H as well as temperature difference. In order to increase H, we need to install a fan and that fan will consume some energy as well as it will consume some space, so it is a negative point. Fine. So everywhere we cannot install a fan, so we cannot increase heat transfer coefficient everywhere. Fine. And the second constraint on temperature difference, this temperature difference is high in winters, but in summers this temperature difference is low. So this point is very less, the temperature difference in summers is less, so heat transfer rate in summers are low. In order to increase the heat transfer rate, we need to increase the surface area, and this surface area is increased by introducing or attaching the fins to the solid surface. Fine. See, this was our original surface. Now we will attach a fin to it. See how. Now see, this was our original surface. Now this is the surface when we have attached a fin here. Earlier the surface area was this one. Now the surface area responsible for heat transfer is this plus this. So this is the AS total. Fine. So what we are increasing by attaching the fins, we are increasing the surface area. More is the surface area, more will be the heat loss by convection. Fine. Now students, see, fins are of two types. Straight fins and annular fins. See, what do we mean by straight fins? Straight fins means that heat transfer will be in longitudinal direction. Whereas in annular fins, heat transfer will be in radial direction. See, what do we mean by longitudinal direction and radial direction? Let our fin be of cylindrical form. Fine. When heat is transferring like this is our longitudinal direction, and when the heat transfer takes place from center to periphery, then this is known as our radial direction. Fine. Now see, again straight fins are of two types, rectangular and circular. Fine. And this rectangular is again of two types, uniform cross section and varying cross section. Again circular two type, uniform cross section and varying cross section. Fine. Now first of all we will study straight fins with uniform rectangular cross section. Fine. Now see, this is our base and this is our tip of fin. Let here the temperature be Ts and here the temperature be T infinity. So what we see, heat will transfer from base to tip. Heat will transfer from base to tip. So this is nothing but your longitudinal direction. Fine. This is nothing but your longitudinal direction. So this is nothing but a straight fin. Now what is the shape of the cross section? It is rectangular. So we see that it is a rectangular cross section. Fine. Now see, draw a cross section here. Now we have drawn a cross section at a distance x from the base. We have drawn a cross section at a distance x from the base. Let its area be A. Fine. Now we see that this area is not a function of distance x. चाहे हम ये क्रॉस सेक्शन इस पॉइंट पे बनाए, इस पॉइंट पे बनाए, इस पॉइंट पे बनाए या इस पॉइंट पे बनाए, एरिया चेंज नहीं हो रहा. सो वी से इट एज यूनिफॉर्म क्रॉस सेक्शन. फाइन. नाउ consider the second case, straight fin rectangular cross section with varying cross section. Fine. Now we consider any cross section at a distance x from base. What is its shape? Its shape is that of a rectangle. Fine. Now let the area be ax. So we see that here ax is a function of x direction. See how? Ax is maximum at base. See here the area is maximum and ax is minimum at the tip. So we see that ax is a function of x direction. So it is nothing but a varying cross section and the direction of heat transfer is like this. So this is nothing but your longitudinal direction. So this forms our second case, straight fin, rectangular cross section and varying cross section. Fine. Now consider the third case, circular fins with uniform cross section. Now see, this is our base and this is our tip and heat transfer is taking place like this. Conduction heat transfer is taking place in longitudinal direction. That's why these are also called straight fins and the cross section is like a circle. So these are the circular fins. And see, draw a cross sectional area here. Let this area be A and the distance be x from the base, and here we see that A is not a function of x direction. So these are the circular uniform cross sectional fins. These are the circular uniform cross sectional fins, and these are categorized under straight fins because the direction is longitudinal. Fine. Now come to the fourth case. Now make a cross section at a distance x from the base. Let the area be AX. Now we see that AX is maximum at base and AX is minimum at the tip. Fine. So we see that AX is a function of x direction. So these are categorized as varying cross section. This fin is categorized under varying cross section, and the cross section is nothing but your circular. So this is a circular fin with varying cross section, and see the direction of heat transfer is longitudinal. So it is categorized again under straight fins. Fine. Now annular fins. Let this be a body, cylindrical body, and the surface temperature be Ts, the surrounding temperature be T infinity. Now we have attached annular fins here. Now see, what will be the direction of heat transfer from center to periphery, and this is nothing but your radial direction. So such a fin is known as your annular fins. Fine.